Hello and welcome to the Edupedia world. Well, in this tutorial, we'll cover about collections Q&A. So this is a question and answers section for collection. I have actually collected some of the questions, and the questions that I have collected are based on their popularity, and for a purpose of giving any interview or giving any Java exam, these questions are really important. So you see we are having multiple questions, and the first question that we have is, how does HashMap work in Java? Well, for this I haven't mentioned the answer because this is something we have already covered. Well, when we talk about HashMap, then the HashMap works on a phenomena of hashing. So there is a concept of hash code that is a method in the object class and is generated for each and every object. So when we say hashing is the phenomena of generating a unique, you can say a hash number or a hash value for every object that you want to store. And how it is actually implemented in HashMap is through again a hash code function. So first of all, we actually calculate a hash code, and the hash code that we get from an object is passed to a hash function defined in a map interface, and now this hash function will give you a hash value. So we have got a hash value up till now. After that we pass this hash value to another method which is called index for. So this will actually give us the correct index of the bucket where we need to get, or we need to put the, or even if we need to remove the element. Okay. So once we get that index using index for method, which takes your hash as well as size of hash map as a parameter, then we can actually locate the bucket. So now once we have got the value of the correct index for bucket, depending upon what we want to do. Let's say if we want to get a particular element, then inside that bucket we can use a for loop to get to our current element. So for that we have to match for the keys, like if our key is matching the one that we want to find, if that is a one, so means that is our element. In case of put, suppose if we have found the hash code and the index, then we have to traverse till the last of the linked list, because each bucket in a hash map is forming a linked list. So we have to insert the element at the end of linked list. So that's why we just traverse till we get the end, and there we insert it. In order to remove, again we follow the same mechanism as we have done in get, and once we get it, once we have where to find our element, then we delete it. Okay, so this is how HashMap works. So I have actually explained you in a very summary, because that is because we have already done how HashMap is already implemented in our previous tutorial. So if you want to understand it in a real detail, then I suggest you to please go back to the previous tutorial to understand that. But as in this tutorial, I have done a recap or a brief of implementation of HashMap in Java. Now, what is the difference between fail-fast and fail-safe iterator? Well, when we say fail-fast iterator, that means iterator that you create for an object, you cannot modify your collection while you are iterating over it. For modification, I mean to say you cannot add or remove the element from that iterator while you are iterating over it. So when you have created an iterator and you are in a while has next loop, and you are doing on your iterator you are calling the next operation. So in between them you cannot modify your iterator. So if you do that, you will get a concurrent modification exception. So if your iterator behaves that way, then it is called as a fail-fast iterator. And if it doesn't throw concurrent modification exception and it will allow you to make any changes, then it is called as a fail-safe iterator. So this is a difference between fail-fast and fail-safe iterator. So I hope so that is clear. Now next question. Next question is, how does the HashSet works in Java? Well, again, HashSet implementation is something like it actually uses HashMap internally to actually uses HashMap internally to place its element in a set. The functioning of a hash set is like it cannot have duplicate elements. So what it does, it internally have a transient private hash map which it uses to store the elements. So whatever element you want to insert in a hash set actually forms the key of that hash map. So it get actually inserted as a key, and for the value part we do also have a dummy object in HashSet, so that is passed as a value. So again, inside the add method of HashSet, you actually call map.put method, which actually put your whatever the value you want to send in the map as a key. So automatically, according to the map implementation, you cannot have duplicate key. That's why you cannot have duplicate elements in a hash set, since these are implemented as a map. Okay. Now next question is, what is hashing? Well, hashing is a phenomena of allocating a unique, you can say a space or a memory allocation, or simply a number which actually denotes to a memory location to every object. Our functioning of hashing is such that each and every new object does get a new hash code or new hashing. So that's an aim, but that doesn't mean that two objects cannot have same hash. It can have, but we intend to make a case where each hash code means we should implement our hash code method in a way that each object does have a different hash code, because if it's a different object then it should have a different hash code, so that the accessibility become easy and your the phenomena of getting the get operation will be faster if hash collision is lesser. So that's why we try to implement it that way. Now next question is, what is the difference between pull and remove method of queue interface? Well, the answer for that is both pull and remove methods from the queue is used to remove the object and returns the head of queue. So both of them does remove your object and will return the head of queue. But there's a subtle difference between them, and that is if queue is empty, then a call to remove method will throw the exception, while call to pull method will not throw exception, rather it will just return a null. Okay. So in that way you can say that whenever you need to use remove method, just make sure you are actually handling the exception properly. But pool is type safe in that case, so that means the pool method will not throw an exception even if your queue is empty. Fine. So that's the difference between the two. From this question I do also remember another question. There is a remove method in the Iterator class also. There is another remove method in your collection class. So what's the difference between the two? Well, the difference is that when we talk about iterator remove method, so when we said that some of the iterator are, fail fast and they will throw a concurrent modification exception if you try to change or add or remove anything if you are, iterating over that collection. So in order to overcome that, we do have a iterator remove method. So if you try to remove the element by using iterator's remove method, then in that case there won't be a concurrent modification exception. Why so? Because it actually works on the iterator. So it will remove that method from the iterator, not from the original collections. That's the difference between two of the remove, one from iterator and one from collection. Now, what is the difference between synchronized collection and concurrent collection? Well, Java 5 has added several new concurrent collection classes, example concurrent hashmap, copy on write array list, blocking queue, etc., which has made several interview questions, because there could be different question asked on different type of collection. Okay. Java also provide a way to get synchronized copy of collection, that is by calling synchronized map for getting a synchronized map or a hash map, or calling collections.synchronized list for getting a array list, and so on. Okay. Now, one significant difference is that concurrent collection has better performance than synchronized collection, because they work only a portion of map to achieve the concurrency and synchronization. So you see what happens in concurrency is that your collection is actually subdivided into portion, so that lock can be acquired on each and every portion separately. So that means one thread can acquire a lock on one portion of your collection and the other thread can acquire a lock on other portion of your collection and so and so. For example, let's take example of concurrent hash map. So what happens over here is, let's say the size of a hash map is 16. So let's say our concurrency level is 4. So it will divide your hash map into 4 portions, each having 4 elements. So that means, 4 threads can simultaneously work on your hash map because each thread can acquire a portion and can start work on that. Okay. But when we talk about synchronized collection, so in synchronized collection is also thread safe, but the difference is that one thread can acquire a lock on the complete collection at once. So that means the complete collection is actually logged, not a portion. So therefore it's a bit slower to use synchronized concurrent collection, and it's locking your whole collection. It's making it completely thread safe by locking it for one thread. It's not aligned concurrency, that's why it's a bit slower. Okay, so that's the difference between synchronized collection and concurrent collection. Now let's move forward and see what's the difference between iterator and enumerator. Well, the iterator duplicate functionality of enumeration with one of a addition to remove methods, and both provide navigation functionality on objects of collection. Another difference is that Iterator is more safe than enumeration and does not allow another thread to modify a collection object during iteration except remove method and throws concurrent modification exception. Okay, so have you got it? What it's saying? It's saying like when we say about iterator removes method, so when we talk about enumeration, so both provides the functionality, to navigate through the collection, but your enumeration is one which is having the additional remove method. Okay. Basically iterator is the one. So iterator actually duplicates the functionality of enumeration but is having additional remove method, which enumeration is not having. And another difference it talked about is like iterator is more thread safe than enumerator. That means it will not allow any other thread to modify the collection. If it try to does, then it will give a concurrent modification exception, whereas your enumeration will not give that exception. Okay, so that's the two differences between iterator and enumerator. Now our next question is, what is the difference between HashMap and Hashtable? Now this is one of a very important question and usually asked in most of the exams and most of the interviews, which includes Java collections. Okay, so I think this is a question that I think every developer should know the answer. So let's go through the answer. So there are several differences. Let's see each of them one by one. So the HashMap class is roughly equivalent to Hashtable except that it is non-synchronized. So your HashMap is not a synchronized and it does permit null. That means HashMap allow null values and keys. So HashMap can have one null key and multiple null values, whereas Hashtable does not allow null. Fine. So this is like one of our main difference, that HashMap is not synchronized and it does allow null key and values. Okay. Now another major difference between HashMap and Hashtable is that, so that we have seen it's non-synchronized whereas Hashtable is synchronized. That automatically means that Hashtable is thread safe. So that means it can be shared between multiple threads, but HashMap cannot be shared between multiple threads without proper synchronization. But Java 5 introduced a new collection which is Concurrent HashMap, which is an alternative of Hashtable, and it also provides better scalability than Hashtable. We can use Concurrent HashMap as a substitute of Hashtable. Okay. Now another difference is Iterator in HashMap is fail-fast iterator, while the enumerator for Hashtable, so Hashtable does have an enumerator, okay, is not. So that means the iterator of HashMap will throw concurrent modification exception if any thread tries to make any change, means any structural change by adding or removing element, accepts iterator's own remove method, but your Hashtable will not throw that. It's having a fail-safe enumerator. It's not having an iterator, it's having an enumerator. Fine. Another is Hashtable is much slower than HashMap if used in a single threaded environment. Why so? because it does synchronization. So synchronization automatically makes your code slow because it will only allow one thread to attempt a, go through a code at once, and thus making your system and code slow. Fine. Another difference is HashMap does not guarantee that the order of map will remain constant over the time. So definitely it's not guarantee. The guarantee cannot be given because HashMap actually doesn't store the order. Okay. So this is one of a final difference. So I think these were the major important questions, although there are several questions that you can find on internet. But I have collected these questions because these are the most important question, and especially the last question, that is the difference between HashMap and Hashtable, then the implementation of HashSet, implementation of HashMap. So these three questions were the most important out of these 8 questions. So I hope so you have enjoyed this thing. So okay guys, thank you very much. Now let's meet in the next tutorial. Thank you.